Okay, great. Hey, listen, welcome back. And with us, we have Celeste and Alan. Raise your hands. Say hi. Okay, we have Maximus. Say hi.
Present.
And Marcus. Say hi. All right, excellent. Okay, hey, listen, let's go ahead and get started with today's lesson. Now, I'm actually very excited about today because one thing that I'll be able to guarantee you is that everybody has gone through areas, especially of parallelograms, best known as rectangles, and also of triangles. So let's start with our first definition. Hey, Celeste, why don't you go ahead and read to us area?
Area, the number of square units that fit inside of a figure.
All right, excellent. Yeah, so this time we're looking at the area that is inside each shape. Now, in our case, let's go ahead and, Max, go ahead and read the next one.
The area of a region is equal to the sum of the area of its non-overlapping parts.
All right, excellent. All right, so the area of a region is equal to the sum of its overlapping parts. So, Marcus, how would you describe this? You need some help, Marcus?
Sorry, what?
How would you describe the area addition postulate? Like, in your own words, how would you say what it is?
So the area region is equal to the sum.
It just means that if you have two shapes and they're not overlapping, okay, you have the benefit that you could go ahead and just like if you found the area of the both, let me see if I can move that over here. Okay, you can add them together and it'll be the area of both. That's all it's saying. You can take two shapes and add them
But what
together.
happens if it is overlapping?
Then you'll have to subtract the overlapping side. You couldn't add it twice. You only added once.
Okay.
That's what it means. Okay, good. All right, Celeste, read the next one. Read the area of a parallelogram. Celeste, yeah, go ahead and read the area of a parallelogram.
Yes. The area of a parallelogram is the product of a base and corresponding height.
All right, excellent. All right, so pretty easy. Now, remember, just keep in mind the height is going to be it's a line you connect the bases or to the tallest point of that shape. All right, Max, why don't you go ahead and read the next one for us?
The
Area of a rectangle.
The area of a rectangle is the product of its base and height.
All right, excellent. So pretty easy. It's one of the first ones you learned. That take the base, multiply with the height, you get the benefit of knowing the area. Marcus, read the last one. Area of a triangle.
Area of a triangle. The area of a triangle is half the product of a base and the corresponding height.
Okay, and why is that so, Marcus? Why is it half?
Because the triangle is just half a square. If you cut a square diagonally, you get two.
You get two, just like I showed right now, right? So we have that benefit. Okay, good. Now let's go ahead and move it to the next one. Hey, Celeste, go ahead and read the instructions on example 1.
Find the area of each parallelogram.
Okay, so walk me through. How would I find the area of 1A?
Of A, you do 24 times 6.
Yes. So first start with the formula, base times height, right? And then as a result, you do 24 times 6. And then afterwards, you get 144 centimeters squared. Now, keep in mind, you're guaranteed that you're dealing with the area anytime you have centimeters squared, because that means you're actually talking about how much space occupies. All right, Max, walk us through the next one. How would I solve D?
You do 7 millimeters times 4.
Well, it's actually 7 meters. Now, the reason why I could guarantee it's meters and not millimeters is because you see the 1M? Yeah, so as the 1M, you get the result that you're going to be dealing with meters squared as opposed to millimeters. All right, Marcus, go ahead and read us C to us.
The area of a triangle is 36 meters squared and the height is 9 meters. Find the length of the corresponding base.
All right, great. So walk me through it, Marcus. How would I solve this one?
Well, you just pop the equation in there. A equals BH over 2. Then you'd fill in all the things we know. So since the area is 36 meters, you'd replace A with 36 meters squared. And we know the height to be 9 meters.
Okay, so
then we just have to solve for B.
All right, good. So walk me through. How would I solve for B on this?
Well, you would times 2 on both sides.
Okay, you
Then you
multiply
divide
by
it by
2
9.
because then it cancels those out, right? Makes it into 1. And then as a result, I'll get 72.
Yep.
If we go to 9b. And what you said the last step is?
So divide both sides by 9.
All right, excellent. And as a result, I'll get the solution that b is
8.
8. Good. So then that means that this is 8 and this is 9. All right, good. All right, Celeste, walk me through, read the instructions for example 2.
Find the area of each triangle.
Excellent. All right, Celeste, so walk me through, how would I solve A?
Your first do A equals B.
Next, it will be 5 plus 5 means 500.
No, it'll be A is equal to 1/2 times B times H. Okay, Alan? And then what do, Celeste?
And then you do BH, well,
How much is the base?
the base is,
The base is going to be 16, Celeste. I know it looks a little confusing, but let me go ahead and clear it up for you. The base is the entire thing of the triangle. So you notice how I underlined it? So as a result, part of it's 12, part of it's 4. So when you add them together, you'll get the result of 16. Now, and then from there, you should be able to see that the height's 5, the one I just did in blue. So as I continue working on this, I'll have the benefit of just substituting those values, and then my solution at the end would be just 40 feet squared. All right, Marcus, walk us through the next one.
Okay. So you have a base of 10 meters, because 2
Okay, good.
plus 8 equals 10.
Yes.
Then you do 10 times 12 to get 120.
Okay, good.
Divide that by 2.
Yeah, excellent. So you get 60, right?
Mhm.
Okay. All right. Now, Max, go ahead and walk us through the next one. Walk us through C.
So you know the base is 13 meters.
Now, kids, is that right or wrong?
What?
Max said the base is 13 meters.
Never mind. I just looked at it.
Okay.
You flip.
So now that you've looked at it, what would you change?
So let's see, that's the base is 12 meters and the height is 5.
Yeah, you could think about it that way because you have the benefit that now you can consider the 5 to be the base or the 12 to be the base. It doesn't matter because they're both interchangeable. So you'll have 1/2 base times height, and then as a result, you'll go ahead and have 1/2 is 5 times 12. So finally, you get 60 times 1/2, which is going to be 30. Okay, good. All right. So now, Marcus, lead us through the next one.
Okay. So for this next one, Okay, so you do 3 plus 4, which gives us 7. And
Okay,
you do
good.
3 times 7, which is 21. Then you divide 21 by 2 to get, 10.5.
10.5 inches squared. Excellent. Okay, good. Now let's go ahead and move on to this one. Okay. Now, Celeste, read us the instructions on the next one.
find the area of each figure.
All right, excellent. Okay, good. Hey, so Celeste, walk me through, how would I solve this one?
How you will do it is
Well, first of all, what kind of shape is it, Celeste?
A1
Well, it's
pentagon,
really,
but
yeah,
it's a
technically you can consider a pentagon, or Marcus, if you had to help your sister
Yes.
out, what would you tell her? What can we do?
It's a square and triangle.
Yeah, it's a square and a triangle. Okay, so for one of them, you'll use base times height, and then add it with base times height divided by 2. So we're going to add two things together. So it's much easier than what I wrote down, because the first step you'll do, Celeste, well, it's actually written down there, is that we know that for the square, it's 15 times 15. And then for the triangle, base is 8. Now, the height is not 17, though. We're guaranteed that the height's 15, the side of the triangle. So once we do all the math there, we'll figure out 225 plus 60. So then our end solution will make the discovery that I could guarantee the result will be 285. All right, Max, walk me through the next one. How would I solve the next one?
Okay, so are those two triangles?
Yeah, there is two triangles.
Okay, so let's go for
And then what
the
else? What else is there?
a square.
And a square. Good. So
10
how many
times 10.
things am I going to add together?
A triangle and a square.
And another triangle, right?
Yes.
Okay. Now keep in mind, do you notice overlapping sides?
Yes.
Yeah, technically you can notice some overlapping sides, right? And
Mhm.
actually the overlapping sides are important for us because it's going to give us clues on how to solve this. Okay. Because if you look at this one, and Marcus, if you could help out your brother, what's one thing you could guarantee him?
I know what the basis for the tiny triangle is for.
What is it? And how would you know?
Because you do the base for the square, then you minus it for the triangle, for the big one.
Yes, I could see what you're coming from, right? So what would it be then? And I think what you're trying to say is this. Okay, this is, we have an overlap here. And let me undo this. This is 10, right? But from here to here, right?
Mm-hmm.
And you also have that this is 10, and it's not, let me see if I can move this a little bit more. Okay. But this is also 10 because of a square, because of the knowing that, see, one of them is a parallelogram and the other one's a square. So since both of them are 10 and we know that this thing's 14, I could go ahead and subtract it and guarantee that this is going to be 4. This little piece right here. Does it make sense for everybody?
No, can you say that again?
Okay, let me go ahead and re-show this. And actually, let me do it with just using shapes. This is 10, right?
Mm-hmm.
Okay. This is 10 here, correct? Okay, so if this is 10 and that's 10, and I move it, like if I subtract, you see how this is 14?
Yeah.
Okay, so then there's 10 in here as well. So that 4 plus that 10 gives you the 14. So if you took one away, you get the 4.
Okay.
Okay, so let me go ahead and put this back at 4. And that 4 is really helpful for us because not only is that 4, if I know this is 4, then I know that this is going to be 10 over here. Does it make sense?
Yeah.
Yep.
All right. Okay, good. So it helps me in not overlapping sides. So on this one, I'm going to have 3 equations. Actually, I should have 3 right here.
Wait, why?
Oh, maybe you don't, right?
Yeah, it would just be
Maybe
24. Yeah, it'd just be 24 times 10 divided by 2.
Well, no,
Area
the
of a
thing
trapezoid.
is, well, we'll have this. No, not area. You can think you're thinking far ahead. We haven't gotten there. Base times height plus 1/2 base times height. So in this case, even though we found out the measurements of the little stuff, which wasn't necessary, Max, but I went through there, I didn't realize that you could just do base times height because remember, this is a parallelogram, right?
Mm-hmm.
So from that one, you should be able to, from base times height and that triangle, you should be able to figure out that this square right here, and let me highlight it, this one right here has to do with this part of the equation, the 10 times 10, right? And then this triangle that's here, that one has to do with this part of the equation right over here, the 1/2 4 times 10, right? And we're not overlapping any sides as a benefit of it. So one of the things that then I'll be able to guarantee you is that we'll have 100 plus 70. And as a result, we add them together, we get 170 inches squared. All right, now Marcus, lead us, how will we solve C?
Okay, so you would first have to find the area of the, what is this? A rectangle, which is just 8 times 5, which is 40.
Okay,
you would
so
have to add that to the triangle, which is 8 times 5 divided by 2.
okay, walk me through the other part again.
So we would have to find the area of a triangle, which would be
Yes.
8 times 5.
Okay. 8 times 5.
Which is 40, then divided by 2.
So then that's going to be 20, right? Now, how'd
Yep.
you know that was 8, the base of it?
Well, because the base of the triangle and the base of the rectangle were the same.
Yeah, and then we have the benefit that those shapes have equal, they're all equal as far as what's across from them. All right, so let's see. Yes, yes, and yes. So as a result, we get 60 meters squared. All right. Excellent. All right. Hey, listen, that was it for today. Thank you so much, kids, for helping me out. Viewers at home, I hope this helps you. And then from there, go ahead, practice, and we'll join us for the next episode afterwards. All right, kids, take care. Thank you for all participating.
Zip.
Okay, say bye.
Bye.
Let's see.